Okay. All right. So we had the equation, and the reason I gave you the equation because I wanted you to see where these pieces come from. Especially you physics people, you're going to be using this equation a lot. Physics does a lot of snapshotting. So you snapshot as something moves. And technically, when we do parametrics, you'll be able to see what time something is, how high it is, how far away it is from the person that, say they shot an arrow. You'll be able to see the path of the arrow, how long it took to hit the ground. You'll be able to see after 3 seconds where was it. You'll be able to like snapshot your path when we do parametrics. But in the meantime, I just wanted you to build this and put this in to your Y1. Now, when you do this, try to make sense out of this as well. When you're looking, see how high we are, we're 300 feet off the ground. Kind of make sense out of this. If you're 300 feet off the ground already, what's your Y max going to be? More than 300. A lot more than 300? No. Even go to 400. Even go to 400. You need to see your parabola turn. So you're going to see this when you do this. You're going to see this over here. All we want is quadrant 1 because we can't have negative time and we can't have negative height. So all we're looking for is this piece here. Your maximum height, do your max. Your zeros, do your zero. And that's all that I think this asked for, right? Was your zero, how, and remember 3 decimals, how many seconds before it hit the ground, and what was its maximum height. Okay? You can always adjust your window. X max, like if you're shooting something up, it's not going to take that long to land. If you give it too long, you'll see a little tiny parabola like this. If you set up to 100, then adjust. Just adjust it. Shorten it. If it doesn't hit the ground, lengthen your X. You can't ruin anything. You can always go back to Zoom 6 and start all over. Questions on this? So stop me if you have any questions. All right. Again, I think the picture is very helpful. This picture, can I zoom? Yeah. Yeah, no, absolutely, I get it. Is it zooming? Okay. This one was very, very similar to the pasture along the river, when he fenced it in along the river. So we didn't need one-sided fence. Again, we maximize area, we minimize perimeters. So when we get through this, we have, I don't care if you called it XX, YY. We should have left statements, which I didn't put mine on. And let Y equal the length. Okay? Your area formula is still basic, X times Y, and you want to maximize your area. Right away, block this out and say this goes in my Y1. Whatever you maximize or minimize is the one that goes in your calculator. So my area, X times Y, is going to be in my Y1. Now I got to have some other kind of information here because I got to get rid of that Y. So I look again and I say, oh, my fence is going to be 1,050 feet in length to do 3 sides. So my perimeter says 1050 is equal to X plus Y, 2X plus Y. Solve for Y in terms of X, transformation, substitute this into here. You can almost see where your X values are going to be. If this is the way this is right now, watch. This is a good way to guesstimate your X values. So if you guesstimate your X values, and you can kind of really see it from here, you can go to your table. Set this equal to 0. Isn't this where my parabola goes? From one end to the other end, where Y is 0? So set these equal to 0. So when X is 0, and when 1050 minus 2X is equal to 0. Do it in your head if you want to. It's a good way to do this. So I've got 5 something. So say 500. Somewhere around the 500. It doesn't have to be exact. So just guesstimate it. So somewhere around 500, I'm going to go from 0 to 500. So set your X value, 0 to 500. Maybe go a little bit more since I was kind of under on this guy. Go a little bit more. Go 600. I just estimated a little on the low side. Go a little higher, and you'll see it hit the ground. Right now, you don't really care where it hits the ground because you're only looking for its maximum. Then what you do is this. You go to your table. Take half of 500 and start at that X. And look right there to see where it's going to turn. And you're close enough. Just take the closest Y to 500. Halfway through the 250. Take the 250Y and just double it, even if you want to. That's it's going to be as high as it's going to go. Add a little bit more to it. Your window does not have to be an exact value. Your window is just so that you can do your max, your min, your zeros. It is just your window of opportunity, let's say. So, can everybody get this? The max? That's your vertex. This is my area. This is my area. This Y. This is my X. This is my length. Plug it back into here would be the easiest place to plug it and find your new Y. So you have a rectangle that has these dimensions. Okay? Can you see? You can almost find your maximum if you did this the right way, right? Questions? Are these getting better? Where is it not getting better? Talk to me.
So you know how to like start the problem. I just don't get it.
Okay, so as soon as you see a maximize or a minimize word, that's where your Y1 is in your calculator. So start like this. I see the word maximum area. Start like this. Y1 equals area. Can you draw out the diagram? So what's the area formula for that diagram? X times length times width, base times height, right? X times Y. So in your calculator, you're doing this. So you say, I can put X, but I can't put this Y. I've got to get rid of this Y. I've got to substitute it out. The only other information they're going to give you is a perimeter. So work your perimeter formula. This perimeter formula is a little different than your standard one because, again, we didn't use one side of it. Your diagram is really important. So I got an X plus Y. There's my perimeter formula. They told me I'm going to use 1,050 feet of fence. That's my perimeter. So now I use this equation to substitute into that one. And then you're going to have to look at your table, kind of guesstimate along your way if you have to. If you have 1050, okay, even do this. You have three sides to share 1050. Divide 1050 divided by 3. It's 300, right? So X could be 300. So start out with X from 0 to 300 and see what it looks like. Okay, so in your table, go to X of 300 and see where it lands. See where you should see a turning point at least. You can do your turning point through your table and get your maximum Y. You use your table and your calculator to help you. Also, kind of throw a little of your common gut in here to say, if I had them all equal, what would it be? You know, so this way you can kind of get through this part. Question?
I thought that the Y it's not at the end. It's through one.
Oh, you can do that. That's fine. You still got the same dimensions, right?
Yeah.
You don't have. It doesn't have to. That's what I'm saying. It doesn't have. As long as you give me a left statement and you come to it at the end. Yeah, that's fine. Yeah, it's the same thing.
Because at first I started out with I put X plus 2Y,
That's fine.
but then what happened was we divided like 1050 over 2.
So you're gonna get the other one first. Yeah, you're gonna get the other one first, and then when you plug it in, you'll get the bigger one,
Alright.
or vice versa. You're still gonna get the both of them.
Then when you find the window, you just do the same thing you did.
Yeah, exactly. Exactly. I helped you start this one because I thought this one was a little tricky. It kind of goes back to the algebra 1 when you have like a certain amount of like 300 feet of wire and you're going to use X for 1. You can use Y for the other one, or it make life easier, 300 minus X. Because Putting a Y in there would be a little bit difficult because they didn't give you any other information. Well, they did, but if you started out like this, and this is perfectly fine, you would still have to do, they equal 300, and you'd have to solve for Y. So you can still work it this way first, and then substitute it in here. You're still going to get the same thing. So if you started out that way, that is absolutely fine. You have to substitute out your Y, so I just thought let's just cut to the chase and do the X into 300 minus X. Your area, don't forget, draw a square. Your area is side squared. Side times side. And you're just putting this in your L1, your Y1. Put this in your Y1. If you have 300 pieces, they want to know a total area. They want to know your total area. So that's going to be a little bit bigger than just your perimeter. So even just do like, if you did 1 times 300 and 300 squared, start off with that. Start off with like 9,000 or 90,000, that's way too high. Start off with like 9,000 and work your way from there. If one was 300, so say it was a half of that, 150 times 150 even, and start off from there. What I was asking for was, your complete graph is a parabola that, well, kind of, and it comes through here. So completely it's through here. This piece we can't use. This is the piece we're going to use. But a complete graph is the whole thing.
Oh.
And we can only use quadrant 1. If you just gave me quadrant 1 as your complete graph, that's fine.
Oh.
That's fine. A complete graph would mean, where did this graph come from? It came through quadrant 2. But I really can't use quadrant 2 because I can't have a negative length of my wire. So I cut it down to quadrant 1. Change your table set. Remember I told you yesterday that change your table set. When you start your table at 0, change your table set. This one's high. Change your table set to 50. Just guesstimate through your table.
What part of that did you put?
This whole thing right there, the one we developed yesterday.
I didn't know if you put the right part in there.
No, the whole thing. The whole thing. The whole thing. If you already set your X-Men and your Y-Men to 0, you won't see the other part of it.
And why did you do the part in black there?
Because if you first put this into your calculator, right? If you put this in your calculator and you did a zoom 6 and you didn't change your X-Mens to 0, it would come from over here if I just changed my other pieces. All we need is quadrant 1. Right now, your X-Mens and your Y-Men say 0. So what I was saying before, if you didn't see that part, is because your X-Mens and your Y-Mens are 0. So if you graph this, so let's look at this. This is what your graph is going to look like. Did it just start right here? What is this a piece of? This is a piece of what? A parabola. So it obviously had to come from here. That's all I was asking. Like, where did this come from? Like, when we threw the ball, we started on top of a hill, wherever we were. We started right here. But technically, didn't your parabolic path come from down here? Like your equation of your parabolic path? It comes from here. And we don't want that part. Right? Because it doesn't really realize, okay, just use this part of your equation. It says, oh, here's my parabola. Coming up, coming down. So it passes through this point right here. God bless you. Better?
I still don't understand why
Okay.
the part in black really.
Okay, let's graph this. Let's graph this. This one was a little trickier. This one, you really had to watch your window because you're looking for the number of units that produces a maximum revenue. Revenue is when you sell something. So your units obviously are going to have to be quite a bit, right? Your revenue would be very high, wouldn't it? So your revenue is going to be high. And your revenue generally goes based on your units sold. You kind of have a maximum because at one point, if you make too many, it costs you to, if you don't make enough, you can't sell them and recoup your cost of making them. If you make too many, you're not making the right amount of money on them, so you're still producing, you're still making money, but it's not profitable. So there's a maximum point that you want to make. And we did this in Algebra 2, and it's the same thing here. It's a parabola, and we just take a look at where we max out, and that's going to be where our maximum profit is. So that gives us our maximum units. You only had the one variable there, right? It's kind of like the other one with the traffic flow. They gave you the x, so you just plug it in. The hardest part was probably figuring out where to put your window. Did anybody have trouble with the window for this?
Yeah.
Okay, so let's take a look at your window for this. How would I even start?
I got it eventually. It was just the number. I just had to keep retrying because I just couldn't find it.
Okay, and so that doesn't hurt either. Sometimes it takes a little bit longer. So, where's my square? I have a parabola that turns which way? Can I tell by the equation which way it's going to turn? Down. I've got my parabola. A point 1. What would a point 1 do to my parabola? Make it wide, because it's going to shrink. It's technically shrinking the distance to 0, which is what makes my parabola a lot wider. So my parabola is going to be wide, and my number is a little high. So even if I graphed it from what I had before, I really can't see much. I need to estimate like where this is going to turn. Now, if I look at my table, I don't want to really go by ones because this is going to have a big one. Maybe I want to go by hundreds. Let me just take a look at my table. Shouldn't my y values increase, increase, turn, decrease, decrease? This is what I'm looking at. Now, if I find that this is going to take me a while to do, maybe change the table set. Maybe go by 1,000. There's no set limit to this. I'm still increasing and I'm already at 1,000. So maybe I want to change my table set to start at 0 and go by 1,000. Just to see where I am. So now, when I look at this, there I am at the 0, there I am at 800,000. What does this mean? E6. Move it 6 decimals over. Sometimes when you scroll over this, watch, there's your number. So I'm looking for this to increase, increase, and then slowly decrease. So look, am I still increasing from 800,000?
Yep.
So now I'm in the million. Did I still increase? Yep. Did I still increase? Yep. Still up. Oh, look at that. I'm about the same in there somewhere, right? I'm about the same. Now I started decreasing. So I go to 4,000. So I'm going to say, okay, set it a little higher. Set it to 5,000. Somewhere between 4,000 and 5,000. So set your max to 5,000. Just for instance, we can always change it. So this is what you would start with. This X scale, if you make that into the thousands, even make this one pretty high, all it does is not be so dark. Your line won't be so dark. The scale makes it so that your line is not like, if I went to the max of 5,000 and I had it by ones, your line is going to be really, really dark. Your scale is by ones. You're saying, give me 1, 2, 3, 4, 5, 6, 7. If I spread it out, it's not as bad looking. There's my minimum again. Now my max, I noticed it was like 2 million something. So I'm going to make it 3 million. I want to see what I see here. So I see my parabola. Ah, I missed it. So what do I have to do? Change my x. Oh, I was only thinking halfway. So to see it, I could almost do a max on this. So I was kind of in the halfway zone. I didn't double it. So now I'll just go and double my x max. Make this 10,000. You technically didn't need to see it hit the ground, but you did need to do a maximum on it. Yeah, so can I do a max now? So it really doesn't take you too long. Play around with this. Another way to do your table set, guys, is this. Start your table set at 1,000. incremented by 1. Just take a look at where am I when I'm 1,000. Well, I'm still increasing quite a bit. Maybe I want to start my table set at 2,000. I want to see where I'm at. Oh, I must be doing something and it's too small to tell. So I just start to look a little bit. Oh, I still see it increasing. Maybe I want to go to 3,000.
When you go to the table, is the purpose of that just to get like an idea where you're
Yes, that's to see where you're turning it. That's what's going to help you set your window. Because these numbers were quite high.
Yeah.
If you're selling thousands of units and you're going to have to make a profit, it's going to, you're selling your units for whatever we're selling them. It's quite a lot of money. Yes.
Alright, so you know how the million or 2 billion or million or whatever?
Yes.
How do you know I can tell?
Well, I
If you scroll
told
from
Maya
table
I went to my table. I went to my table. You had to look here.
Wouldn't it take forever just to scroll down all the way down?
But were you listening to any of what we just did?
I was.
Okay, so 2 ways to do it. 2 ways. Hyung, watch. 2 ways. I could start it somewhere, because I know I'm going to sell a lot of units, right? I'm a big company here. I'm selling units. I have to make a lot of money. I don't want to just make $500. So I'm going to make a lot of money. Either start your table like this, or I would rather do this. Start it at 0, increment it by like 500. Now, watch. Do you see it still increasing? You have to scroll here and watch it. See it increasing? I want to look for where it increases and then it decreases. I'm still up, I'm increasing, up, I just decreased. Did you see it? So, right in here, that didn't take very long, right? But don't scroll by 1. You'll be there forever if you scroll by 1. So, play with this. Can you start all over and zoom 6 and start all over? Absolutely. Okay. All right, this one should have been pretty good.
It's pretty easy.
Yes. This is like your typical throw a ball and now it's for 2. How far does it go? When does it hit the ground? And the concept of doing this is go back to Zoom 6 and start again, because how long does it take a child to throw a ball?
Not very long.
Not very long, not 2 million things for X, like probably 5 seconds or less before it hits the ground. Now, when we do parametrics and we add your third variable, it's pretty cool. We'll actually throw one ball and throw another ball and see where they meet, see if the people can catch it and where they're throwing it. We'll actually run a roller coaster and have somebody throw a ball and see if they can catch it on the roller coaster when we add your third variable. So we keep doing, that would be kind of cool, right? So, how was this? Was this okay?
I got this part right.
Got that right. Oh, the last line drawn into 5.
I should have put this first, but one year that I put this first, it threw everybody off in the big ones because we practiced doing the big ones, and then when they got to this one, nobody reset their X's, and I was like, oops. This one was nice, right? All right, so we're good with this?
Yep.
It looks like this. And you know I have a hard time drawing. It's not as bad as it sounds. Here's the trough. Here's the turned up parts. They're turned up like this. I would never expect you to see this. Now, we want a picture of this cross-sectional piece right here. So, we want to maximize its area. So in Y1 is your area. Okay, I have a 37-inch sheet that's going to be turned up equally on both sides. So if I don't know how far this is turned up, and this whole piece right here is 37, how do I find this piece right here? I have a whole big sheet, this is 37. I turn up 2 equal parts of X. x and x. So what is this piece left in here? 37 minus 2x. Okay? This is the length. And my width is x. Okay, so there's your length and your width. So what's the formula for area?
X times Y.
X times y, or in this case, x times 37 minus 2x. Okay, so that'll help you get that. You are looking for the maximum x for this. I would not expect you to have drawn this because it took us a while to figure out what this was trying to say.